Make sure it shows up over here. Make sure I'm muted. All right, I'm live there. Does this show? Yes, it does. All right, today is September 19th, 2024. We're here in CSE466 at ASU, and we are currently working on the topic of return-oriented programming. Memes. Some of these memes I just don't get, but like you're touching on things that are there, so I assume that you're getting it, and you're not just like throwing random words on pictures. If someone wants to explain some of these to me, I'd love it.
Is this like
The address of the open func, some way to get RAX, and then the address of read func. And I'm not entirely sure how that one is mission critical. Do you got me?
Well, it might be because like the output of the open func versus call goes into RAX, and that's the
Okay. All right, I'll take that. That's solid. All right. That's because somebody is a good programmer.
Yeah.
Okay. They aren't making assumptions about the file descriptor that would be returned from read. I get it now. That's a way better meme now. Because initially I didn't get it. But I was like, there's something here. It's not connecting for me. A note on this is like, you don't have to be a perfect programmer, right? File descriptors, it's not like guaranteed that they are sequential, but in practice they are. So if you know that there are no open file descriptors at the time you call open, the next file descriptor that should be returned is 3. That doesn't work. It's wrong. Okay, maybe you had a false assumption. Try and hard code 4, right? Maybe you just can't. If this was set RAX, maybe, but like then you couldn't call open either because you need to set RAX to trigger a syscall, right? But you don't. The point being there is that you don't have to be a perfectly correct programmer as far as your ROP gadgets, right? You don't have to take the return value of open and pass it into read. If you can, that's great, but flag is flag, so do what you need to. Yep. This one is like this image on ROP has reappeared. This is like the 4th or 5th year of somebody hitting this image, but it's totally valid, right? I think Jan's videos call it getting Lego pieces and putting it together, which is why we have this one over here. Everyone's thinking, all right, great, we're going to play with these little Lego pieces, and it turns out ROP isn't as easy. I don't know why they're looking at object dump. That sounds like pain, but ROP really is trying to create a message or create a program out of all of these tiny Lego pieces or all of these tiny letters to make something that is somewhat sane and understandable, right? And so both of those are valid analogies. This one I didn't like initially. All right, and I thought about it, and because I thought it was just a really lame chain pun. Right? Is that what it was supposed to be? Because I found deeper meaning. All right, upon reflection, which is how I made it up here. Because I think last night it was posted, I wasn't a fan. I was like, chain, whatever. And then earlier today, while I was putting together these slides, okay. So it's also freeing the person. And ROP chain or ROP gadgets are kind of the first thing in this class where we are talking about, and I'm not going to go into this whole exploitation primitives idea, but it's the first time where we now have control flow, right? We can arbitrarily execute whatever we want within some constraints. Where earlier we had memory corruption, we were kind of limited in what we were doing. Now with ROP, we are truly freeing our exploit to do whatever it wants. And this has a number of implications. One, it's extremely powerful. 2, it means that once you start writing your ROP chain as a student, what you do is going to be totally different from the person next to you, which will very likely be totally different from the person next to them, which can be totally different from what I do, right? Because once you get an exploit to the point where you can arbitrarily execute something, it's enumerable, but you have a ton of freedom, right? Like back in shell coding, everyone kind of defaulted to good old chmod, but there's nothing that stops you from calling open read write. There's nothing that stops you from using send file. There's nothing that stops you from using any of these other approaches. And so that is still true in ROP, except you just have more constraints on yourself compared to shell coding. And how you, like what gadget you find will influence what you think is the easy path. And so what you think is the easy path and what somebody else is may not be the same. Logistic things. I said this on Tuesday, but I assume there is some subset of students that only watch one lecture despite being told to watch both. I do have office hours. I do have a room. It's now Friday at noon, as was requested. The room is BYENG 222, so that's the big old brickyard building. This will not be streamed, just for anyone that is an online student. The idea here is I can give more direct help to whatever the specific thing is that you are stuck on. But if I'm going to do that, that means I can't have students on stream. I can't have your code on stream. There's a number of things there that kind of break streaming. If for whatever reason you are unavailable for this time and you are like, hey, I really want some one-on-one FaceTime to talk about what I'm stuck on, DM me on Discord. We'll sort something out. I'm up here like 3 or 4 days a week, so it shouldn't be too hard to catch me as long as we schedule it in advance, because I typically am doing things when I'm up here. So with like a week notice, we can probably sort something out if needed. Recitations. Recitations are Monday, Wednesday, Friday. Initially, we were doing the great pwn.college Hour of Power. Well, it turned out that 365 was pretty powerful as a class, and it kind of dominated that room, I think was a safe takeaway. Over the past couple of weeks as I've stopped by. And so I have moved us across that little fountain area to BYAC 270. Same time, it's just a neighboring building. The idea here is if we stay here, it's just for 6-6 students. It's a lot easier for TAs or myself to help you with whatever you're on. Technically, 365 students can overflow into that room. We haven't seen that yet, but if for whatever reason they get hard stuck, they are welcome to be there, so don't kick them out. But yeah, we did that starting yesterday, and that has been pretty successful, I would say. It was received well. Dojo life. Not yesterday, it feels like yesterday, but it was Tuesday. Tuesday I had this like slide that was like, put this in your GDB init, right? Or else things will explode and cause pain. I don't think you have to have those now, so I would suggest you remove them. There's still some gotchas there. I'm not happy with. No. So you don't have to have the magic things in the GDB init for this module. If you're working ahead and in some other module, stuff's probably weird and wonky. I'm only fixing things that are impacting this class, because these are like super short, quick fixes that need to get reverted to make things sane in the greater scope. There is a long-term fix for some of these weird GDB behaviors. ETA, I'm going to say 2 weeks, but don't hold us to it. So that should be by the end of this module. If not, I will just hot fix whatever the next thing is that we do so that it causes you less pain. And if there is secret pain hiding here that I don't know about now, you guys voice it, I'll try and make it right. Either by fixing it or bribing you with extra credit. But hopefully fixing it, because you'll say so earlier. If you didn't watch Tuesday's lecture, I bribed everyone with 0.5% of extra credit. So yes, please let me know so that I can fix it or try and address it, because the dojo is a complicated beast, and so there's things that sometimes don't behave how you would expect on a normal Linux system. It's like somebody earlier today brought up ROPper, which is just another tool like ROP Gadget, but they're like, hey, I prefer that for whatever reason that's not on the dojo. I'll add that because I'm tool indifferent, right? Whatever you like, as long as it's somewhat well known. I'll get that on the dojo sometime, probably by this weekend, like early this weekend, because that's an easy thing to fix. So let me know if there is something. Twitch is requesting RP++. RP++ should be there.
It is. I just used it this morning.
Okay. I totally believe that it may not be in the path of it. That's a whole separate discussion. But yeah, if there is some other tool that is well known for these type of things, let me know and we'll try and correct that. Tuesday's demo kind of went off the rails, and some people asked me outside of class, hey, what happened? I didn't rewatch it, but earlier this morning while I was eating my breakfast, I had an epiphany as far as why the demo went off the rails. I had half of the story right. This is the full story. So I did not chown the binary to be owned by root. and I did not chmod it to make it set UID, so the binary wasn't running as root. Now you saw me fix that live in class. And then somebody with a keen eye that apparently was like really searching the lecture video was like, and then it still didn't work. And the answer is yes. And that's because I was working in the home hacker directory. Does anyone know why the home hacker directory matters here? I know it's on the slide. Yeah, make sure people are at least looking at it. The home hacker directory on the Dojo is mounted no suing. This is something that you can see, and it's something I should know because I tell people it constantly. Yeah, but that's where it's a do as I say, not as I do. If we run mount and then we grep hacker, well, we'll see that this is the mount into your environment. And right here, when this is mounted, it's mounted no suit. And what that means is that any file that is on this mount, so in that path, if it's set UID, the system will just ignore it. So even when I fixed that, because I was in home hacker, it didn't matter. And the only time that we saw the practice flag come out is when I was just like, oh, sudo su, and then it's just I'm root anyways, and so nothing was actually elevating privileges. I was just being root. I could have catted the flag anyway. Does that make sense? So like silly things happen to all of us, and then I don't know if I alluded to it on stream or not, but I at least mentioned it before stream. At that point, I was definitely quite sleep deprived. And so sleep is important because that's how you remember that these things matter. Okay, I do not have a bullet here for what are you stuck on. However, I will take some questions and see if I can make it fit into this, but I really want to hit these things. So does anyone have anything other than these items where you're like, OMG, I need to know this? Okay, what do we got?
Okay, so it's more just like theoretical, like more like conceptual questions, but just two of them. So first of all is, how is like these tools like ROP Gadget knowing how long to make these gadgets? Like how do they know like to make it like a certain length that like when they're showing the output? And my second question is, since these instructions like take a certain amount of bytes, hypothetically, we could just also just jump to like right in the middle of an instruction and then that would give us a completely different instruction, like with the new bytes.
The first one's a reasonable question. The second one, I feel like you already know the answer and you're just baiting me.
Okay.
But if not, I'll answer it. I'll hit those two and I will come back to the other hand that I saw. So the first question is how does ROP, well, I'm going to use ROP Gadget, but there are other tools, right? How does it know this gadget is, I don't know, how many is that? 1, 2, 3, 4, 5. How does it know this gadget is 5 instructions? And why is it not like 12, right? Well, in truth, a gadget is really only defined by its terminator, right? So the shortest gadget you could have is ret. You could also have a gadget that is literally just jump, right? Those are your two terminating. A gadget must end with that, because if it doesn't end with that, then you're not redirecting control flow somewhere else. So a gadget must end with ret or jump. And if we look at, for instance, these two conveniently, you'll notice that the addresses are just one right before the other. This is AD0, this is AD2. We're actually referencing the same series of instructions, and we could probably go all the way up to here. All of this is actually the same 5 instructions. We're just chopping off the first end and saying, well, if you don't want to pop R12, you can start at the next one. If you don't want to pop R13, you can start at the next one. You don't want to pop R14, start at the next one, right? And so the gadget is defined by its terminator, and then technically it could go infinitely back, right, as long as there's valid instructions. Like one of the earlier ROP challenges, it doesn't tell you to use gadgets. It tells you to like call win, right? Well, win is a function. It is an arbitrarily long, series of instructions. A function is a really, really long gadget, right? They're one and the same. So we could jump anywhere that is a valid interpretation of instructions that is executable, and we could argue that it's a gadget, where a full function would be the limit.
Okay.
Now to the second question, it was okay. These aren't good instructions for that. Let's see if there's one that is. So I don't have a good way of demoing this. Oh yeah, I do. Okay. Good old GDB, man. It's the answer to everything. Okay. So if I examine, let's break it main. If I examine 20 instructions at RIP, I get this. And I started kind of arbitrarily interpreting instructions at 19 AD because that is where things lined up based on normal execution of this program, right? But you'll notice this is a 1-byte instruction, push RBP, not very interesting. This right here, this move RBP RSP is a 3-byte instruction. And so I could look at the instructions right here. What's up? Okay. Examine 6 instructions at that address. And I'm going to get exactly what I started with, right? Move RBP, RSP, and everything else interprets the same way down. What happens if I increment this by 1 byte, right? And so now what I'm doing is I'm just arbitrarily choosing this memory location and saying, well, what happens if we pretend these bytes are instructions? What does it look like? It looks like this. And that makes some sense. It's similar. All I did was I cut off this first byte, which if we remember from shellcoding, the first byte of many 64-bit instructions turns something from a 64-bit instruction to a 32-bit instruction, which is what we see there. But there, I could actually increment it 1 more, and now I get something that looks quite a bit different here. Now I have in EAX48. It's not inc, it's in. I don't know what it is, right? I would have to go ask Felix and be like, well, what is in, right? And there's nothing stopping you from doing this. Some tools do this. Like I think ROP-Gadget does, or at least it has an option to do so. Some tools that search for gadgets do not. And so that is why, one of the reasons why some people may have a preference for one tool over another. Now, searching through every possible offset of a binary for every permutation of possible interpreted gadgets is an intensive task for a non-tiny binary. So there are reasons why you would not want to do that. And if I were to do this and be near where RET was, what you'd find if I did this all the way down to RET probably disappeared, right? And so if I don't have a RET, do I have a gadget? No. Like I need a RET or a jump for it to be something that is worth considering. Now, can you coincidentally happen to have a gadget that's hiding in between instructions? Absolutely. I don't believe we do that to you here though, because that'd be a little bit cruel for a introduction to ROP. But it is possible and it does work. There are real exploits that do exactly that. Where you interpret bytes in an executable region of memory as instructions, but not at the intended offset of those instructions. Cool? All right. There was one more hand over here. Yes?
So going back to the no SWIT, so suppose home hacker is not set to ID, it means no child directories of home hacker or not.
I apologize. Could you repeat that?
Sure. So like going back to the previous concept, for like the Tuesday's demo, if I were to like reproduce that, I would have to work in a directory other than home hacker or any of its child directories. Is that correct?
That is correct. So for Twitch, the statement was when I was talking about no SUID home hacker, kind of messing around with this. How do I deal with that? I said what the problem was. How do we make that not suck? And the answer is we will copy our demo folder over to temp and then just work out of temp. All right. And that is exactly what I plan on doing for the rest of the day, is working out of temp ROP so that this doesn't trap me as we talk about these things. Good question, very real, and exactly what I'm going to do. Any other short, easy questions before I start driving the bus?
In the ROP gadget on the left hand side, that was was the address of gadget?
On ROP gadget,
Yes, on the left-hand side.
this right here.
Yes,
And the question is,
that is the address of all those instructions.
this is the ad. So this is a bit of a trap. Okay. This is why that whole PIE ASLR rant that I had that ate up part of the day matters. So I'm doing this on challenge baby ROP. So if I check sec challenge baby ROP, we'll see this particular binary has no PIE. If it is a no PIE binary, then the literal addresses that are shown are literal addresses that you can use.
Does that correspond to all the instructions?
Yes. So if you were to overwrite RBP, and we'll see this in the demo, or we can. If we were to overwrite the saved RIP with this right here, we would execute this instruction, this instruction, this instruction, and then rep. So one address, a gadget can be more than one instruction. A gadget is defining where you're going to set rip to, and then it's going to fire off until we ret or jump, right? Because when we ret, we're setting rip again. If we were to jump, we're setting rip again, right? And so we were defining, all right, instruction pointer, go burr, and then it jumps, and then we go to the next gadget, and we go burr, and then we jump, right? Now, whether you have one instruction, which is nice and easy and digestible to understand, like pop RDI ret, I'm doing one thing, or you have 30 instructions. It's the same mechanism that's occurring. We're setting RIP to some point, and it will go until a jump. I guess technically you could have a call, and that call could ret, but that's getting pretty fancy. So it's until some instruction that re-gives you control flow, right?
Is there a restriction on the length of instruction? I think it has to be.
That's based on the tool. The question was, is there a restriction on the length of the instructions or the length of the gadget? So like right now, for instance, ROP gadget, quite sanely, doesn't show duplicates, right? So there are multiple locations that could have that same thing. We have dash all through there. Somewhere there is a length argument. Did you find it?
I think it's a depth.
Is it depth?
Yeah.
So search depth for search default 10. Okay, yeah. So if I set the depth to be like 60, right, then hopefully it would throw out a whole bunch more here. It's not at the same address, so that maybe that's where the miss is here. Okay, the address that it's telling me is the address of the first instruction, and then what happens when the CPU interprets that first instruction? What does RIP do?
Goes up to the next
It increments and goes to the next one. And so this memory address is not where all of these instructions are literally written. This memory address is the location where the first instruction is, and then we assume that the RIP will continue to increment and march forward. That's why when I had, for instance, that GDB, and I was examining 6 instructions right here, it's not always incrementing by 1, right? This is one instruction, this increments by 2, this increments by 3, this increments because the instructions are variable length. But RIP doesn't care. It's just going to march forward, and we're going to interpret instructions and go forward. We're doing the same thing with our ROP gadgets, where we are just setting it somewhere and then letting it go, right? We set it free, it rets back to us. All right. Any? Yes, one more.
So how come when we use a ROP gadget, it will show the addresses of some commands? I won't see if I look at object dump whether possible. Is object dump omitting some commands, or is it ROP just looking at some nested library?
So I don't want to spend too much time on stream digging into this. The statement for Twitch was, I use ROP gadget and I get instructions that I don't see in object dump. And the short answer is these ROP specific tools do things like interpret instructions in between instructions. These ROP-specific tools will interpret anything that is in executable memory, right? Where object dump is specifically saying, here's what this function is. Like using object dump and then like grepping for a specific instruction would be very rough because you don't know, you don't know how big your gadget is, right? Like if I grep object dump for, I don't know, pop RAX, that could be in the middle of some giant function. It's great that I found pop RAX, but I don't know how much nonsense is going to happen afterwards before that ret, which is what gives me control. And then for these challenges specifically, did you see the Tuesday lecture? Cool. So you saw my demo that didn't quite work. At the very end, I had like this function that was useless and it just had like this magic assembly stuff. So object dump isn't going to do a very good job of parsing some of the ways that we can insert random nonsense in there, right? Object dump is assuming that this is like a sanely built binary. And so depending upon how object dump decides to interpret that, it may not show you every instruction that's even in the binary. That's why these specialized tools are definitely the way to go. All right, anything else? Cool. All right, so we'll see. Today is day 2. I actually dry ran this stuff. All right, I was very concerned about things not going, and I even automated my chunk and chmod so I can't mess it up. So the first thing that we have here is I'm going to build this example.c. It's very similar to the original example, and it's going to have no PIE. So let's remove my a.out. Let's make it. Let's make sure that it is what I say it is. We have no PIE. That's great. In the interest of time, I will show you the example code. All right. It's pretty much the exact same thing as what I failed to finish on Tuesday. So we have a main function. It calls challenge. Challenge is going to say ready to receive input. It's going to read up to 512 bytes in its buffer. It's a buffer overflow. There is no canary we saw from checksec. So we can overflow into the saved RIP. Conveniently hiding down here to the object dump point, I have this function. This didn't need to be a function. I could have inserted these bytes via other mechanisms. So this one probably would show up in object dump, where I am just like manually inserting these gadgets here. All right. Why? Because I am trying to make it trivial for you to perform the ROP, not to search for things, right? And you'll find this is the case if you use ROP gadget on some of the earlier challenges. We want you to perform the ROP, not spend all of your time figuring out how to do it. Did I name things? I need to go back into temp, ROP, 2. Good, we can have do.py, my favorite file. User ben m, Python 3. Okay, what's a quick and easy way? Somebody's complaining about ARM. This is not a class on ARM. It is different on ARM. What is an easy way for me to find this offset? It's going to be the same number as Tuesday, but hit me with the ultimate solution here. How do I find out what my padding is from where I send in input? I'm sorry? Cyclic values. So I'm going to say, for those that don't remember, cyclic 100 gives me some giant string. I'm going to do cyclic 500, so I got a really big one. I'm going to stick it here in yep. So now yep has that. We are then going to GDB this binary. I'm going to run it with yep. So it's going to take those inputs, and we immediately seg fault. Is it all over? No, this is exactly what I wanted. What is useful to me here? Okay, so one of the comments was info frame. This tells me where the saved rip is. And what we see here is that saved rip at the point of seg fault, which is when that rep was going to occur, is RSP. So we know this is the value that we control that is saved rep. And we can get it from here, or we could know that, hey, we're seg faulting on a rep, and so we know that this and that are equivalent. Both get us to the same place. How many bytes of this do I need to copy? 4. By default, it's 4. You can specify more. So I got QAAC. What do I do with it? Cyclic. Okay, in Python, it's cyclic find. In the terminal, it's cyclic-L. If you can spell. Cyclic L, 264. All right, real quick and easy, we know our padding bytes are 264 bytes to get to the saved rip. So now let's start stubbing this thing out. From pwn import star, context arch equals AMD64. I will say that this context arch matters a lot if you start doing fancy pwn tools ROP stuff. It will be wrong if you do not set the context and start using fancy pwn tools ROP stuff. So if that's happening to you, that's why. Okay, I have some type of payload. My payload I know is going to be A times 264 padding bytes. I don't know what else I need to add yet. And then I'm going to have P equals process. In this case, it's A.out. We're going to P send payload, P interactive. Okay, so now the question is, what else do I want? What do I want to set or overwrite my saved return address to be? Because this is going to be everything to get there. Where do I want to go? I'm sorry? The win function. That would be swell if this had a win function. But this does not. Right? The thing I started with on Tuesday that I did manage to finish had a win function. But we're going one step further than that. Now we do not have a win function. And one of the statements here, which is what ROP is, it's the natural extension from going from one overwrite to many smaller ones. If I blow away all this space, because I already showed you this exists, we have gadgets, right? I like trivially put them in there. How do I find them? I'm going to use ROP gadget. Now, you probably read that and already saw what I injected there, right? However, it makes sense to search for the easy things, right? And so you could grep for RAX, okay? And maybe I see through all of this that there's a pop RAX, which is an easy gadget to use, right? I don't have to like call it a bunch of times. I can just give it some constant and it goes in where I want. Question.
Why don't we just grep for pop?
Why don't we just grep for pop? I agree. And that will give us a whole lot of useful things, right? There's two things that you almost always want to grep for, at least in these challenges. I'm not saying in real world exploitation because we're making some things easier here. Pop, because that's an easy gadget where you can just set whatever you want. And the other thing would be, and will change, this is why this is relevant as you move through the challenges, the other thing that you would want to look for is syscall. And if you have having the syscall gadget in the binary is unusual, right? In the real world, this won't happen, but we can have it here because we're not trying to make things harder than they need to be for you to understand how ROP works. Okay, now this binary is PIE. There was a question about these addresses, or this binary is not PIE. There's a question about these addresses. Because this is not PIE, can I use these literal addresses? Yes. How do I use them? I take the addresses. Okay. So this kind of goes back to our shell coding. So now we're doing it where I only have these things. And this is really all I need. For the purposes of the demo, I'm going to call it a win if I can open the flag. Okay. I'm not gonna open read write. I'm just gonna call it there. You can envision we could do the same thing with other syscalls. All right, to finish it out if you wanted to go there. But in the interest of time, if I open the flag, we've successfully won. Because I can set 3 registers and perform a syscall. If I can call open, I can call read, I can call write. That's the logic here. Yes.
Why not just do chmod instead? Just one.
Okay, there's a comment, why not just do chmod? This goes back to the amazing chain-breaking free mother clucker there, all right? The double entendre there of breaking the chain, ROP chain, haha, and then freedom. You can do whatever you want, all right? What I'm going to do is open the flag.
Okay.
Okay, so one way that I mentioned doing this, and remember that you need to P64 these values. because the values that are being popped off of the stack into RIP are 8 bytes in length. P64 will let me pass in a number, and it will ensure that it's 8 bytes. I wouldn't need to have all these leading zeros. Now, in the interest of pretending I know how to code, I'm going to actually define these things. What do I have? 1187. I'm going to say pop RAX equals that. I also have pop. I don't think I need RBP. It just happens to be there. Pop RDI is the same thing. Please check me for typos, because that will derail us. RDX here. Do I have a pop RDX? Okay, well, I don't have a pop RDX. I have pop RDX, pop RBP, and it is located at 1189. I probably need a pop RSI. Do I have RSI? Yes, I do, 1185. And then the last thing that I need is this syscall. It is 1180. Does everyone agree with my magic constants here? See, I'm just yanking them from here to there. Whether you use comments, whether you name your variables, make it so that it's readable. Especially if you're going to ask me for help, and if you just show me a whole bunch of hex addresses being appended right next to each other, I have no clue what is going on. All right, it has happened. It's not only helpful for me, but it's helpful for you when you are trying to figure out what's going on and where's your mistake, right? So my goal here is to call open. Anyone know what the syscall number is for open? If you don't know, who do we ask? Ryan A. Chapman.
2.
Yeah, 2.
All right, Ryan A. Chapman.
Right.
Yes, 2. All right. Now, pop RAX 2. I then need to set RDI. So P64, pop RDI. What is RDI for open? It's the file name. So what should somebody said pointer? This is a very important thing to be aware of. All right, you can't just throw bytes in here and be like, I throw in flag, and then it's going to it's going to interpret /flag as a pointer, and you're going to segfault. Common mistake, not specific to ROP, but just in general, right? Keep in mind that's a pointer. Now, there's 2 ways that I could think about this, because this is one of the sub-problems that people are stuck on. I need to get flag into memory. If you recall shell coding, we had this same problem. I need to get flag into memory. Did we always get flag into memory? Or did we realize there was a path of less pain? What was our path of less pain? Symlink magic. Okay? So what I need is a pointer to something that is a string. Right? Does it need to be /flag? Does it need to be, if I make a symlink named A, does it have to be A? Well, if my symlink's A, the answer is yes. But I could change the name of my symlink, right? So let's, instead of setting our symlink first, let's think about what strings are already in this binary, right? There's probably something we can use. So there's a strings command if you're unaware. I'm not running a challenge. All right, there's a bunch of strings, right? All I need is literally 1 character followed by a null byte. That is enough to define a C string for our purposes. And one of the nice things about using the binary itself is this is not PIE, which means if I know the address of this string, it is a constant. It's not randomized. Now, strings doesn't tell us the address. There may be a flag to do it. I don't care. I don't know, because my true love is GDB. So what I'm going to do is I'm going to run this challenge. I'm going to break on puts, because you know what you put? Strings. All right. So we break on puts. We continue. I am now at puts. What is the first argument to puts? The string that's going to be puts. If we didn't know, We could man puts, and we see puts, yes, puts just takes a pointer to a string. So this is a super easy way. I don't care what the string is, right? I just care that there is a string. So if we print RDI, this is the address of some string. If I want to know what is this string, it's ready to receive input. Now, does this mean I need to name my file ready to receive input? No.
Be exclamation mark.
What's?
It could just be the exclamation mark.
It could just be this exclamation mark, because in the minimum case, a string is 1 byte. I don't even think it has to be a printable byte, although you may have some problems making the symlink work on Bash, right? But 1 byte followed by a null byte is the minimum case for a string. So where is this exclamation point? In memory. This is a no PIE, so this address is real. It'll be consistent every time I run it. I could examine, I don't know, 60 characters at RDI. All right. I don't know that, and I don't really care. Where's the first null byte in this thing? It's over here at the end. Okay, so it's going to be that 21 is the exclamation mark. So I have 1, 4, 1, 5, 1, 1, 7, 1, 8, 1, 9, 1A. Did I math? I'm gonna trust
the bill byte. Sorry.
Yeah. So we want the string to start before the null byte. So it'd be 1A. If we were going for the null byte, you're correct. It'd be 1B. So the address that I'm interested in is 201A. All right. I'm gonna put that here in my script. We're gonna call it the magic string address. Change that so it has an A, and we will append that to our payload. Okay, I need to set RSI and RDX. RSI, I don't know. Imagine I don't know what that 0 is the right answer here, right? For O, read only. I can use pwn tools to get this constant. I probably showed this in an interactive session at some point, but we can use the same thing in our script. So I'm going to say constants dot O read only. And then pwn tools will take care of the rest. I don't care what the number is. It's going to put the number there. All right, that's going to set RSI. And then I need RDX, so I need to fix that up. RDX, and in this case, it can just be null. 0 is 0 is 0. That's fine. And then the last thing I need to do, payload plus equals a P64 of that syscall gadget. So this is my full plan here. Does anyone have any questions about what I did and why I did it?
I'm just a little confused. Shouldn't it the order of keys, the instruction and the values themselves?
I'm going to start here. The order of
what I'm thinking, the first 2 instructions for
Okay.
arrays and the 2.
Mhm.
In my mind, I think the 2 should be first and pop arrays should be second.
Okay.
Maybe I'm missing something.
All right, that's not true. I'll show why in a moment. Do you have something else looking at this
I
right now?
noticed that we're actually, it's supposed to be pop RDX, pop RBP, because that's the actual
Ooh.
one we have there.
Okay, so you're thinking ahead. All right. So the comment was, I don't have pop RDX, right? I kind of just made that up over here. And my Python code would explode because it would tell me that pop RDX doesn't exist. So instead I have pop RDX, pop RBP. How do I fix this so that works?
Pass 2 values instead of 1. One for RDX and one for RBP.
Okay, the statement from the class here was pass 2 values because this is really going to, and this is why naming things is useful. I named this incorrectly. My Python code would have blown up and said, hey, you don't have this, exactly. Right? And so I would have failed early, and I would have failed in a easily identifiable way.
That's why I pointed it out.
Yeah, no, that's why, we are hackers, and at the end of the day, if it works, it works. But by not just having a little bit of semblance of organization can save you a lot of pain when you're like, why doesn't this work, right? I tell you, go look at it in GDB because your code looks like garbage. And that's fine. Like, you can figure it out from GDB, but it's a lot easier to figure it out from the tool that you have. And so the comment was that because I'm actually popping two values with this gadget, let's put two things in front of it. And that is the correct answer. So, right on. All right, let me catch up here on Twitch. Okay, Twitch caught me. You know, sometimes I do things incorrectly on purpose. So, good job on Twitch. PopRDX is not real. The question is whether enclobing RBP is important. Okay, so that's another point that Twitch brought up. It isn't going to matter for this literal demo, but it can matter in other contexts. What is a side effect of me running this gadget? I really only wanted to set RDX. A side effect of it is I had to set RBP. What happens if somewhere down the road I call something that needs RBP? It's going to dereference a memory location relative to RBP. I can't use that because I have now ruined RBP. RBP is just off limits, right? And you know, I could try and do some earlier things to like push RBP, pop RBP, figure out what RBP is and get RBP in here and like move it around, like do some shenanigans there so that I don't break RBP. But in this literal example, I'm breaking RBP. And so if there were anything that I was doing after this syscall, I have to know that those do not rely on RBP. That includes the leave instruction. Yes?
I don't know if it's been covered, but I'm not able to figure out how pop RX and the value 2 is going to set 2 in RX.
Okay. The statement was, I don't understand how pop REX followed by 2 is going to set this value. And this is where GDB will save us. So anytime you're not sure like how something works, it is more than a meme. Use GDB and step through this stuff until it makes sense to you. So I changed my script to be GDB debug. There's a bit of a trap here. I won't be able to open the flag. So I'm going to sudo su, because GDB drops privileges, remember. So I sudo su, then tmux, so that I can still split this. We go back to temp ROP 2. We run do.py. Did I not make it executable? I did not. chmod plus x do.py, do.py. Okay. So here I am in GDB. Because I started it from Pwn tools, it's going to put me here at _start. It just does that. Where is the point where I actually care? Where does my ROP chain, where do I gain control? After giving input. So I should break at read?
You can break the challenge return. Yeah.
Okay, so it's called return-oriented programming because we gain control at return. That's why all of the gadgets end at return. Returning is what we're doing, right? And so it needs to be the return that is influenced by our memory corruption. All right, so one of the statements was it's going to be, see if this works. Let's break at main. That gets me there. Let's break at read. Okay, and then I'm going to finny. So this is the, I broke at the location where the input was ingested, and then I finished, so now my memory corruption has occurred. Things are not looking very good there, which is not a good sign. Okay, well, we'll see what happens. What I'm interested in is what I'm corrupting. Okay, we're on the stack. Our overflow is on the stack. We're corrupting the saved RIP. Now I'm going to hit this leave instruction. Whoa! The stack suddenly changed, and now it looks like what I'm doing. Does anyone here know what leave does? This is a very important thing to know for this module. What does leave do? This is more important for the second half than the first half, but it's important.
I'm gonna take a guess. It's like doing the epilogue of a function, right?
Right. So the statement for Twitch here was it's part of the epilogue, which it is. Your functions end with leave followed by ret. And if we looked at a function prologue, in the interest of not stating it incorrectly, we'll just look at it. what we do is we push RBP, we move RSP into RBP, and then we subtract RSP. That creates our function frame. Leave is doing the reverse. So leave is going to take RBP and pop it into RSP, and then return. Hopefully I got that right. It's the inverse operation. And so before we executed that leave, the stack that it's showing me is the current stack frame. But once we step through that leave, RSP gets cleaned up because we're eliminating the function frame because we're about to return. And now we see the values that we've overwritten. Now, one of the questions here from the class was, how does the, and do it over here, split that off. Temp ROP 2, do.py. How does pop RAX followed by 2 get 2 into RAX? I think it should be the other way around. I don't see how this is pulling it off, right? This is black magic to me. Well, where am I? I am at this ret. The first thing that I overwrote, was the address of, it's like black on black there, but we can see it right here. I'm going to ret to pop RAX followed by ret. So if I just step one instruction through that ret, I am now at the beginning of that first gadget. That's going to pop RAX. Where does pop RAX get the value from? The stack, right? And where are we writing to? The stack. So the stack serves two purposes for us here. It is both the series of places we're going to jump and if we are using pop, where values are going to come from. And so if we were to look right here, we're about to pop RAX. What is at RSP? 2. We step, and if we were to take a quick look at RAX, RAX is 2. And now we're about to ret again. I go to my beginning of my second gadget. It's pop RDI. What is at RSP? It's this address I came, and Jeff is nice enough to dereference it and say, hey, this interprets as an exclamation mark as a string, which is what I want. Now, in the interest of time, because I did not create my symlink, I should probably do that before we call open on this thing, right? Otherwise, it's just going to be like, yeah, this didn't work. So we'll go into our temp ROP 2, which is where we're playing. What do I need to do? ln-s something. I think it's, I didn't hear any actual statement there. There's some mumbling.
I think just ls-s and like the file one link and the other file one link.
Okay, yeah. It does take 2 arguments. Both of them are files. Which one is the destination? Which one's the source?
Destination is second. The source is first.
Okay. I'm just going to say yes because I could interpret that statement either way. So the first argument is where I want to go, which is flag. The second argument is the name of the thing. One of the things to be aware of if you're going to be using this in Bash, there is a difference between single quotes and double quotes. I don't know if exclamation mark literally would work here, but if you single quote something in Bash, Bash will leave it alone, not do any interpretation, any substitution. It is just absolute truth as far as the string. If you use double quotes, Bash will do some substitutions. This isn't a class on Bash. This is just something for you to be aware of. If you want a literal string in Bash, use single quotes. And what we see here is I now have something that isn't a literal exclamation mark, and that is going to be a symlink that points to the flag. All right. We're chilling here. We're popping RDI. Hopefully everyone is on board what's going on here with the gadgets and moving and grooving. Now, here's that interesting gadget that was like, it does what I want, then it does some other BS, right? So this is a gadget of more than one length. It's actually got a NOP in between, right? So it's a four instruction gadget. This old popper RDX, it has the side effect of currently popping 0 into RBP. When we ret, we get to our syscall. The question is, did this work? I did not get a negative number. I mentioned if you know that, or you are functioning under the assumption there's only standard in, standard out, standard error that are open. Your next file descriptor should be 3. I successfully opened the flag. Does anyone question that? All right. Any questions about that first demo? Second one, I'm going to run out of time, and it's going to have a lot more fancy things going on. But that is the base case for how to do ROP with literal addresses using P64. And I think it is worth doing that initially so that you understand the concept of what's going on. Because if you immediately jump to fancy tools and then it blows up, you can't make sense of what's going on in GDB. And so having a script that looks like, leave me alone, looks like this is very clean. It's very easy to understand what step, what value is right or wrong. So I would definitely consider doing that initially. Okay, so now we're going to get to the second amazing show here. We're going to make my PIE version of this binary. My PIE version of this binary is a bit different. So if we run this, it says puts is located at, and it gives me a leak. And then it says ready to receive input. Now, if we try and do the same thing, and do it down here so people can see.
It's GOP right now.
God, yeah. GOP gadget sounds cooler. Where we can do our, all right, you know, Robert, you're punking me. There's clearly.
Do we want pop as well?
Oh, you want pop, not push? Okay. Looking a little bit rougher here. All right, and the challenges will get to this type of state pretty quickly, right? The ones that have super nice, pretty things in there are meant to be nice, easy, debug it, understand what's going on. Now, I ranted quite a bit on Tuesday about what does a leak get me, and I looked at VM map and we said there's contiguous regions of memory, this, that, and the other. I'm not going to repeat it. What do I get a leak of in this thing? Okay, puts. Where is puts? If you don't know, that's fine. You can just say, I don't know. How do I find it?
Object dump.
Object dump was a statement, and that would be incorrect because this is something that appears at runtime. So if I go to temp ROP2, we run my binary. It's 807. Now it's DE85. Now it's, right? This is being impacted by ASLR. And if we were to check sec this binary, we would see that it does in fact have PIE. Right? I did disable the canary. So where is puts? You know what my favorite tool is? Oh, GDB. So we start this bad boy. Let's break at puts, because I'm assuming that's how it's printing it out. I could be wrong here. It probably is wrong, actually. Let's break at printf. And continue. Let's fini. Hopefully I get the challenges printing. Oh, I'm not in Tmux. It's all ogre. Here is the thing that the challenge is spitting out to me, right? It's intermixed in my GDB output, since I'm not using Pwn tools here. I could copy this address. And I could, since I have Jeff, this is a Jeff thing. VM map followed by the address. I'm sure Pwn debug has something similar. I don't know it. If I run VM map and I specify an address, it will tell me what region of memory this is in. Now, it's a nice long scary string with nicks. I'm not going to go into what nicks is. Hopefully one day that will not be visible to you. What we really care about is the very end, which is somewhat cut off. It does say libc.so.6. Okay? On a normal non-Dojo system, this would actually be /lib/x86 GNU something or another /libc.so6. All right, the paths are a little bit different because of Dojo reasons. But it is, in fact, libc. And if we were to VM map here, we see that it's specifically this executable. Now that's the loader. It's this executable region of libc. All All right, cool. Based upon what I said on Tuesday, what does getting a leak in libc allow me to get to? Anything that's based off of libc. So how do I know it's based off of libc looking at this VM map printout? I did this whole highlighting, counting thing, and everyone was sleeping on Tuesday. I believe the Thursday people can get this. How do I know what's contiguous in memory? Contiguous means right next to each other. Subtracting the offset. Okay, so I think you're one step ahead. So what I'm trying to find here is if I get a leak that's in here, in this region, everything in this literal region from E7000 to 43,000 is contiguous because it's mapped as one blob, right? All of this is just one blob, and whatever is mapped there is mapped there. And the literal location, the literal memory address may change and randomize due to ASLR, but say there's something that is at puts plus 12 bytes. It's always going to be the same thing at puts plus 12 bytes. But I can expand this thought more than just this region. You don't have to for this module, but this is something that people miss, and so I'm going to reiterate it. This right here, this region ends at EE7000. This begins at EE7000. These are right next to each other. They're mapped differently, that's fine. This ends at 43,000, begins at 43,000. They're right next to each other. It's fine. How about this? 99,000, 99,000. They're right next to each other. Great. 9D,000, 9D,000. Great. 9F,000, 9F,000. Great. AE,000, AE,000. Great. AF. Holy cow, there's actually a whole lot of things that I can get to. Right? By just getting one leak in a contiguous block of memory. Hopefully I didn't fail to match up numbers here. But you get where I'm driving here, right? And as was mentioned by the class here, I can deal with that by calculating an offset from something that I know to something that I want. Now you can do all this by hand and you can write the math and do that, and that's fine and dandy. It's worth doing once or twice just to know what the pain feels like. And you should be able to do this. Somebody says, I can't remember a time when libc wasn't contiguous. Exactly. Libc always is, and one of the things that people don't realize is libc and the loader also are pretty, I don't want to say always, but very often contiguous. Okay, so we could do all of this fancy math. We're going to vim do 2.py. We will not have time to finish do 2.py. I'm just looking at the clock and I know where we're going. From pwn import star, context arch equals AMD 64. One of the things I had in the slides was talk about the GOT PLT. Regardless of what I talked about today, I was going to record a separate video on it. So I'm just going to do that. And that's what you're going to get on that. Because then it'll be nice with slides and diagrams, and it'll make more sense. A better use of time. So I have this. One of the things that we do with pwn tools is we create a process, right? Has anyone messed around with an ELF? Typo? Who am I typing? Right there.
I've been using it with
Somebody says they kind of have been using this thing. So
I did use readelf in the red edge.
Okay, so somebody said I used readelf, right? Readelf is kind of cool if it decides to run. Oh, that's read. That makes sense. Readelf gives me a bunch of info about the sections of the ELF. It's a bunch of static information about the literal ELF file, right? Is useful, not what I'm going for here. So pwn tools itself has a object. I can get it from p.elf, or I can just call elf on a binary. Okay. This gives me a Python programmatic representation of this elf. And you're like, all right, well, that's great. One of the things that is in here, for instance, is symbols, which is a dictionary of all of these addresses of something, right? Now, very much like when I was talking about ROP gadget, are these addresses, which are printed as decimal, we can convert them to hex, it doesn't matter. Does this reflect where things are at runtime for a PIE binary?
No.
No. because you can't know what runtime is doing from a file that's sitting on disk. So that's a problem. But we don't just have, we can do more with our magic elf thing. If I go back to GDB, I want to copy and paste from this, because I'm not going to know this path. I'm going to copy this giant libc path. And I'm going to say libc equals elf of whatever the heck that is. If you're unaware of import IPython, IPython embed, that just lets me run the script, and then it will pause and not do. Gosh dang it. It will give me an IPython session. Do two. It'll give me an IPython session after that code's ran. Okay, so I have this libc thing. All right, it's still just an elf. I have this symbols thing, and this is a dictionary. What is the location in this libc symbols of puts? Well, on a libc that's sitting on disk, it's this location right here. Remember, numbers are just numbers. It's all the same thing. That is the location of it sitting on disk. Does that tell me where puts is running? No. Okay. So far this is pretty useless, right? Except it isn't. If I find, did this print? Oh, I didn't. P. We're gonna YOLO some stuff here. P. We're gonna print P received line. Nice. Okay, that was good enough. You can imagine that I had this. Does everyone know how to grab this literal value programmatically using pwn tools? Yes? No? Yes? No? I'm getting no's. Okay. We're going to abandon the IPython. We're going to go to a better place.
No Python.
No. It's still Python, all right? It's just not IPython. So, yes? Yes. So the statement from the class here was process has something called p receive until. Twitch, yes, you're talking about magic. I don't trust that magic due to Dojo insanity. It may work, it may not work. I'm literally demoing things that I know behave as I expect. The comment from the class was I can use p receive until. We probably dealt with this at some point. Right, we're working with challenges here. So this binary spits out something I'm interested in, which is an address, but it has some other garbage before. I don't care about the other garbage. So I'm going to receive until, what does it say? Located at. And then I have the space. The space is important. Make it a byte string. Now, and that's going to, in my script, it's going to eat all of the output from the program until this 0. Now I want to capture that string. What do I want to use? How am I going to get the rest of this line? Hint, hint, nudge, nudge.
Read line.
Okay, I could read line. I like receive line. I think they're the same thing. So we can receive line. Now receive line, I want this to be the puts address. Okay. Now, in the interest of time, I'm going to. What is the type of this right now? If I call puts receive line, it's a byte string. A byte string, a functional equivalent string, but yeah, byte string is the most technically correct answer. What do I want if I want to like do math off of this number? I want a number, right? It turns out it's really hard to add and subtract strings. Maybe Python will do it, but I have no idea what will happen. So I need to turn this into a number. And does anyone know, if it's fine if you don't, how you would do that?
From bytes, X to power.
Oh, I don't like that. I don't like that. That is bad. That's why we ask. So the comment from the class was I could use int from bytes. Okay, so this is where types will really mess you up. All right, there are bytes, there are ints or like numbers, there are characters, and then there are the bytes that are the characters. Right? Int from bytes is going to interpret those bytes as a literal integer. And you will end up with a number, but it will not be the number you think you have. All right. What we have here from p receive line is a series of bytes that represent the characters that are the numbers. And then just as a nice anecdote, since we did receive line, it's also tail-ended. The tail end of it, the caboose, is a new line character, which we also don't want to interpret. Right? So we got to do a little bit of cleanup here. And this isn't that insane. So what does this do? This is slicing. I'm slicing off that new line character. I don't want it. The next thing I want to do is I want to make it an int. There are other ways to do this. There are many other functions. And you could convert characters to ints, to characters, to bytes, to... All right, you can go through whatever circle of insanity you want. But in the end, what you will end up with is this. This, years down the road, you'll be like, that was the way. Okay? So if I am going from a character representation of a number, what I'm saying is I want to receive the new line, because the rest of it is just my number with the new line character. I'm dropping the new line, and then I'm saying those characters I want to interpret as an integer with a base of 16. And that should give me a nice, sane number. And we can print that from our Python code here with an f string. So I think puts is at, I will say hex of puts address. I strongly recommend, if you are working with addresses as variables, leave them as just numbers. I don't care that Python prints them as decimals. In the end, that will cause you pain if you try and hex things early, because then you start trying to add strings and like things aren't right. The hex function doesn't make it a hexadecimal number. It gives you a string that is the hex representation of that decimal number. They're all the same. All right, so I have this. In the interest of time, we're going to add a little bit more magic here. So I had this libc elf thing. And we said that the values that it shows me for these symbols are all a lie and it's all lost. Well, that's because we haven't informed pwn tools, where is libc? We can do that. We say libc address.
Why dot?
Why what?
Why are we doing a dot for this?
I am setting a member of the libc object.
Okay, so this is not like, this is on purpose and we're not like doing a typo. I just want to make sure.
As far as I'm aware.
Okay.
So like prior to earlier today, I would have said libc.base, but it turns out that this version of pwn tools doesn't use that. There's probably another way to set it.
Okay.
Which you may know.
I thought this was like setting a variable. That's why I was asking.
No, so I am setting the address property of libc.
Okay.
Of this libc elf thing. So by default, the address of this libc elf thing is going to be 0. That's why everything that it tells me is a lie. It's only true literally on the file. Okay. But if I want to try and get this thing to reason about what's going on at runtime, I need to tell it where is libc at runtime. And so we can say libc.address equals my puts address minus, and you'll have to think about this one, symbols puts.
This makes sense.
This makes sense. Okay. Because this doesn't feel like it does to a lot of people when they first look at it. I'm taking the address of puts, subtracting the distance into libc, which gives me the base address of what's dynamic, running for this running instance, and then setting that over here. Yes?
For setting this, change the offset in the libc.symbols.
Oh, you're one step ahead of the game. The question was, does setting this make libc.symbols not useless? And the answer is yes. So I will then print f, I think open is at, and we'll say hex What do I want? libc symbols open. Okay, so I have this going on. The question is, can I debug this in negative minutes to prove that this is accurate? The answer is maybe. I'm root, right? Yeah. I need to run do2.py. That is PID 10688. I'm going to GDB attach 10. I can't say a number and then 10688. 10688. Where's my print here? Okay, so it thinks open is at this address. I attach GDB. If I print open, let's print. That's not what I really want. Why did I choose open? Where am I? I'm inside of read. Let's finish. What did I miss? Is GDB lying to me? I promise you. Let's examine the instruction at that address then. Come on, GDB. Examine the instruction at that address. Okay, it is open64. So it is where open is inside of libc. Okay, so what we're able to do here, and you'll notice that I haven't even sent my payload yet in my script. Because the challenge said that before my input. And so I can programmatically grab my leak and use this to then dynamically construct my payload and send it into the challenge. I'm like 4 minutes over time. Hopefully that is useful. Any last minute questions? All right, we're calling it there. I appreciate me keeping you late.